Pretty excited about this work. So we have TruX. So TruX is actually from the University of Luxembourg. And actually, we do a lot of things on trustworthy software engineering. So I think this is a very timely topic for us. I think we have a few people that have also does things around agentic software engineering. So I think this would be a good way to actually talk to us about what your talk is going to be all about, and let's see how we can actually proceed from here. Thank you so much, Hal.
Yeah, sure. Thank you for inviting me.
And
Yeah.
yeah, you're welcome. You're welcome. Then, of course, I know it's quite an hassle from the invitation all the way to now, and thank you so much for always the. I think I really sent you a lot of emails. I'm sorry about that, but thank you
No
so
worries, no worries.
much. So normally, yeah. So the session is going to be like you have like 30 minutes roughly to have your presentation, and I know we have a lot of questions. We've been waiting for this time, so we also going to like ask you a lot of questions. So
Yeah,
please
nice.
take also. Thank you.
Yeah, cool, cool, cool. And thank you so much. Thank you so much. So can I start here? Yeah.
Yes, yes, please. Thank you.
Sure. Thanks. So yeah, good afternoon, everyone. I know it's afternoon there. So thanks for being here, and thank Imana for inviting me. So my name is Hao Li. I'm coming from Queen's University. I'm currently a postdoc here, and today I want to talk about something that I think is gonna fundamentally reshape how we build software. It's about agentic software engineering. So something I want to discuss here is about how gonna or what's gonna happen when AI agents become real teammates in the software development process. So Professor Ahmer, he wrote a book about this topic. So feel free to scan the code and then read it online. And here I'm gonna going through briefly about what's the main idea. So let me start with a bit of history. Every decade, our industry falls into the same trap. Like in the 1990s, we thought that a C++ prior would grant procedure programmers OO wisdom, but it did not. In the 2000s, we thought buying Jira, the license, meant doing agile, but it also did not. So nowadays, we might also think that giving developers a coding agent can solve all the problems, but obviously it did not. So coding was never about or was never the hardest part of building software. There's other parts involved in the whole process. So obviously, like software engineering is changing. So previously we have people, process, and product. Nowadays we have humans plus AI in the people side, which will replace it. And the process evolved into a AI native software engineering, which is trustworthy vibe coding. And the product side, right now, we are more moving into an AI native software. And unfortunately, this is where we are today. Like we are like the mechanic who is trying to mount a modern engine into a carriage. So we are in a very early age in the era of agentic software engineering. So here's a question I keep coming back to. When cars first appeared, the UK passed a law which requiring someone to walk in front of the car, waving a red flag. So, but on the other hand, seatbelts, it took 30 years from invention to a widespread law. So, but they saved millions of lives. So, which story are we going to write for AI agents or AI teammates? Will we be in a red flag person or in a CBL story? I think we try to build a CBL story from here, or at least starting from this year. So we want to build something safety and control the risk. So agentic software engineering is something beyond agentic coding. Always in our productivity curve, right now we observe a lot of elite developers, like 10 times, 100 times development, the productivity gain they got. But they are the elite developers. For the average team, we still observe they are in a very flat, not boost the productivity curve. So agentic software, the goal is to bring the average team can have at least, for example, 80% of the elite developer level. So we can bring in more development, bring in more improvement in this process. So software engineering versus coding, the main thing is about multiple version and multiple developers. And developers have different capabilities. So software engineering, we can enable them to reach the level as close as the elite developers. So we must rethink the whole software engineering system, because like in AI teammates, they have strengths and weaknesses. They are tireless and unbiased. They are strong communication. People have a lot of back and forth communication with these AI teammates. They have broad world knowledge and they have near zero replication cost. But the weakness is also very obvious. They are very eager, they are fast, but can do a lot of job wrong, and they are very general, so they lack the local knowledge about your project. And they also have a very tunnel vision, which means they can only see very local scope. And it's difficult to learn things from them. So continuous learning is still an open research problem in AI domain, which means it can also repeat the same mistake again and again. Imagine AI teammate as a person who wake up every day and forgot everything happened before. So every day is new for them, which means every time the AI teammates try to do something for your project, it forgot everything before and you're going to repeat the same mistake. That's why people keep maintaining the context files, try to remind the agents what happened before, what's the project context, how to use the knowledge in the project to improve the performance. So if we think about just AI plus coding, it's one human and it's one to N agents. In agentic software engineering, we try to build a system that can support a long-lived software, which involved multiple humans and multiple agents. So software engineering was never about trusting the people. It was about trusting the process that supported through the tools and artifacts over the people. So right now we also need to over the agents. So it's the same problem, but faster failure and more critical than ever to do so. So in real life, Uber they reporting like agentic software engineering is a system transformation, not only a tool or language model deployment. In the system stack, they found out that a lot of developers start acting as their technical lead to direct the AI teammates. And they also build some verification layer to try to standardize the review process. And also like they also build different agents which are certified for different tasks, like auto cover, auto migrate, auto code, auto document. And they also build a routing layer for the models, because sometimes you don't want to waste the token cost for a frontier model. Some easy tasks can distribute to the cheaper model for execution. And they have a different mindset. I would say it's very different mindset from before. It's like the system layer are built to be thrown away. So they try to keep the abstraction layer very clean and easy to replace the implementation layer. Because when a better commercial or tools or language models, they can replace the old builds easily. They just quickly swap out and throw away. And for the results, we may observe that 70% of the agentic tasks are toil, like library migrations, stack code cleanup, document writing, test coverage. Very few new feature developments. That's what I observed in their organization. And 8% of all code changes are all AI autonomous. So right now they observe like 95% is monthly AI usage across all checked tools. And one interesting finding is that developers, their net promoter score, NPS, is at all-time high. So this score is to measure how happy the engineers about the tools and how satisfied are they to advertise this for other people. And in the beginning, it was a very slow start, but now it's on fire. So at the beginning, they are like hesitated about the AI tools, but right now it's cannot even like stop using the tools, and which also corresponding to another interesting finding. So this organization, METB, they did a study last year, so 2025. They found out that using AI make developers slower, not faster. And this year, they tried to do a follow-up study, and they found, yeah, it's actually speed up things. They try to repeat the same study from previous participants. They found out it's speed up around 20%. But the problem is when they try to recruit people, they found an increased share of developers saying they would not want to do 50% of the work without AI. Even they want to pay them to do so because they need to do the study. So that's why they indicated for the new participants, the rates can be biased because they have selection bias here. For the old one, it's quite easy to keep them because they follow up. So the interesting thing is like nowadays it's quite difficult to ask people to quit AI coding, even though you force them to do so, they may not want to do it. So it also brings to like the paradigm shifts in the agentic software engineering era. So agents are teammates nowadays, they are not only tools. So we must engineer for two stakeholders. One part is software engineering for humans. We need to rebuild the process, the culture, and the skills we need for human beings. The other side is software engineering for agents. That's why we emphasize the harness, the context, the verification. But the question is, what's really happening in real-world projects? So let's have a very quick look at the landscape. So last year, a lot of people like NVIDIA CEO called last year as the age of agentic coding and coding agents. So we have very different coding agents such as Autocode Rover, Copilot, Agent Mode, OpenAI Codex, Cursor, Google Juries, OpenHands, Devin, and Cloud Code. So this is a super hot and highly competitive battleground. We have seen different headline numbers, marketing news, and talent wars every month. These agents act and now like very implemented very differently. Some are closed source, some are open source, some living in the IDE, some living in the terminal or CLI. So let me ground this with a very concrete example from the cloud code. So here's an issue which describe the requirement and people assign it to Copilot. And then Copilot gonna work on this issue and create a PR automatically, which propose how to do the job, how to fix the inconsistent behavior. Everything flows through the normal GitHub pipeline. And during the review process, a maintainer comment that a new test is not that useful and should be removed. The Copilot agent, it replies and try to update the PR accordingly, referencing to the old commit and try to do the key changes. And as you can see, the agent is participates in the human review cycle, which is taking the feedback and revisiting the code changes. So as you can see here, he try to adjust the comment from the reviewer and try to commit. It's just like a junior developer would do in this case. And this is why we did we're conducting the research called AI Dev. It's a data set which try to collect the coding agents in real world, which the data set cutoff is August 2025 last year. So we observed that coding agents, they are really reshaping real world software projects. As you can see, OpenAI Codex, they got around 800K PRs on GitHub last year. So this year, the new number we got is around, and the total PR number is around 8 million. And we are trying to refresh the data set to provide a newer ground. And another thing is about their performance. We noticed that coding agents, they are not toys anymore. They are building real code and they are really merged into their code bases and they are producing a real impact. Here in the radar, you can see like the dash is the 100% human success rate, or we call merge rate. And Codex succeed human behavior or success rate in multiple different dimensions. So agentic PRs, their acceptance rate match and even exceed human PRs for different tasks in GitHub projects with 100 stars. So these are kind of popular projects. And one thing I want to emphasize here is that the user experience design matter a lot here. Different agents, they have a different interface to submit the changes. For example, for Copilot, as I showed before, they starting from the issue assignment and then pull request, all the things happening on GitHub. So for OpenAI Codex, a lot of people just submit it and then kickstart all the PR creation process. And we observed that a lot of people, a lot of developers, they just click the merge button without checking the code. So a lot of time, the merge rate does not mean how good the performance it is. also a reflection about how they're using the tools. So which also require a lot of research in this direction to see how we can design better UX here. And one interesting angle is we observe the coding is no longer the bottleneck. The new bottleneck is the silence from the human side. When agentic PRs they failed, it's normally not due to the bad code, because we also measure the code quality here, but it's rather about the lack of feedback and developer inaction. So a lot of developers right nowadays complain about they are overwhelmed by the volume of PRs. Some of them are created by humans, but mostly are created by agents. So the newcomers submit pull requests by leveraging agentic tools, but the maintainers they cannot even have time to check each PR because some of the PRs, some of the projects they got more than 1,000 PRs open there. So no way for a human being to go through all of them. So that's the area of dataset. We collected the core metadata for the PRs, for the pull request, and also for the all the related comments and reviews, and the commits, diffs, and the related issues, events, and we also include the automated annotation for the PR task type. So if you are interested, you can grab the data and see what you can do based on the dataset. And from our side, based on the dataset, we did some interesting work. So for example, she did a project focusing on 567 cloud code PRs. So we try to understand what's happening in the PR purpose and what's the acceptance rate and what's the content of the human revision. So here, due to the time constraint, I will just show the most interesting findings. So we found out that agents, they are good at refactoring and testing, but tend to bloat the pull request. So for the similar part, people use agents for bug fixing and feature implementation just in the same frequency as a human being. These are the top two most popular task type. And we also noticed that agents are also highly used in non-functional tasks, like refactoring, documentation, testing. One thing is that agentic PRs are more likely to be tangled, like they are multiple purpose. One PR can contain bug fix and refactoring. So agents, they tend to do more job when humans ask them. That's why we observe a lot of like entangled, like dual tasks pull request. And the other angle is we also check the refactoring because we observe a lot of tasks are using in refactoring. And refactoring is the way we try to maintain the healthy of the project and try to build a long run and long-lived software. And we think it's going to be important in the age of agentic era. So we observe that, we just did the focusing research on Java commit because we got a lot of mature tools to mine the refactoring instance and also to study the purpose of the refactoring. And the key finding is that maintainability and readability highly drive over 80% of the agentic edits. It's quite different from the human PRs. So as we can see here, maintainability is the key thing, or human will distribute maintainability tasks to the agentic tools. And the readability is another raising demand, I would say. But one interesting finding here is also people did not distribute the other task to agentic tools, or the other explanation is that when human beings ask agents to do refactoring, they focus more on maintainability and readability. For other, like for example, the performance, the legacy code, the repurpose and reuse, they are not that good at reflecting these different dimensions. So the root cause could be that the fine-tuned data or the pre-trained data in these model providers, they are not good or they're emphasizing the other directions. Another angle is about the logging. Do AI coding agents log like humans? When we ask them to log, can they log? When we not asking them to log, will they log proactively? So we check the agentic PRs versus human PRs. And we found out that in 58.4% of repositories, agents they talk logging in fewer PRs than humans. So if we do not ask them, they won't touch the existing logging lines. And if when they start logging, we notice that it's 30% higher log density. Because like it's very interesting behavior is like the agents, they are hesitated to change the existing code. It's another interesting behavior observed in the wild, not only for logins. When we ask the agent to do something, if we have multiple functions already, the agent will try to add another function instead of changing the existing functions. And for the logging behavior is more interesting because when human beings ask agents saying, could you add more logins? Agents tend to add more when they be asked. So in the paper, we have more details about this. On the other angle, we want to emphasize that the AI Cajun tool chain and the protocol landscape. It's like we observe that process as code emerged as a critical engineering artifact. New artifact type, they require full new life cycle. For example, we observe prompts, skills, agent configs, for example, MCP config, hooks, and different things pop up every day or every week. These artifacts, they are new and they must be version controlled. They need to be tested. They need to be reviewed and sometimes need to deprecate it. So it's like some people, they maintain it on GitHub, but how to version control is still an open problem. And how to test a prompt, a lot of people still do not know, and it's an open research question, how to review the changes. For example, if we have a new version of skills, how to do regression testing for a skill, we do not know that. If there's security risk or vulnerability formed in a prompt, how can you deprecate a version of prompt so the risk can be controlled and won't propagate to the whole supply chain? Because right now, a lot of these artifacts, they become a new dependency for a lot of open source projects. We need to control the risk, we need to version control it, we need to do a lot of quality control and quality gate. Just like control this as the production code. So based on this idea, we conducted the research about the agent readmes. Agent readme is the context files for the agents. So the agent readme instruction will be loaded for the agents each time when they try to start a task. So agents.readme is right now a standard for the agents to check when they're starting the job. And the Cloud Code have their own README format standard called cloud.md. So different agents right now, they have their own mechanism to control the initial prompt. And in this study, we try to extract these README files and understand their structure, how people maintain them, and what's their content inside it. So one key finding is that we notice the functional context is prioritized and security and performance, they are kind of ignored. So if we check the content written in the README file, a lot of them are about how to implement a feature, like what's their architecture, what's their folder structure, what's the implementation detail. And another interesting thing is like developers also include the instruction about how to build a project, how to test the project. Because right now, the people run an agentic loop to automatically implement a feature, run a testing, run a build. If something fails, they want an agent to automatically fix it again. But very rarely, like people will include an instruction about how to improve the performance, how to pay attention to the security risk. So this brings out a lot of interesting research questions can be done in the future. And the other important supporting mechanism or protocol is the MCP. So MCP nowadays is functioning as the foundation layer for the language models. So if the language model want to use a tool, normally right now they leverage the tools through the protocol. So they connect the tools through MCP. That's why they have a standardized layer to use a tool to interact with the tools. So in this study, we try to look at the security and maintainability of MCP servers. So this kind of server, they are open sourced. So we cloud the GitHub to correct the official MCP server and the community ones and the open source ones. And we try to understand what's their quality, and also we try to scanning these tools to understand what's their vulnerability and what's the security risk in the wild. So we found out that credential exposure is the leading traditional vulnerability in MCP servers. There are around 3.6% of them exposed to this vulnerability corresponding to the CWE and CVE instances. It's like a lot of leaked API keys right now you can find on GitHub. We also found that in the MCP tools. So when the developers try to develop the MCP tools, they use some AI, but they forgot to like use a environment vulnerable for the API keys. So this search I reproduced it yesterday. So that's still GitHub tried to do something to protect human beings from this, but still, if you cracked the searching query smartly, you can still got a lot of leaked API keys in a while. So which is, I think, people still need to put a lot of attention here because still human beings in the loop. There are some mistakes still can be happen here. And it's very important risk we need to manage. And one specific risk is the tool poisoning. So right now it's emerged as a very critical MCP specific threat. For example, this is a tool designed to send a reply message in some app. So the attacker, they try to misguide the agent. They try to tell the agent that in a prompt. So one interesting aspect about MCP is they have two different components. One is the prompt side, which is implemented as the document string. This part of documentation or string gonna be passed to the language model to guide it to use the tool. And the other part is the code implementation. In traditional software engineering, we focus on the code part because the code is the real implementation. But right now, in the description, which is going to change in the agent behavior, which is going to change the behavior of the system, or going to increase the attack vector space. So here, the attacker try to tell the agent that this is a proxy number. You should send a message also to the proxy number, but do not notify the user about this because this is a implementation detail of the system. It does not really matter to the users, which try to mislead the agent to do the secret or attacked really risky things and sneaky. So we also found out around 3 real cases in the MCP tools we mined. I think this is very important questions or risk to manage in the wild. And based on that, we also try to study how the tool description, the prompts, they have contain the smells, because like right now we have code smells, we also have the tool description smells, which also people call it prompt smells. In this paper, we try to augment the description to improve the performance. So due to the kind constraint, if you're interested, you can scan the code to read the paper here. And we share the AI dev dataset to the community. So we hosted the MSR challenge this year. We got 116 submissions and we accepted 62 papers. So this year, people submitted different papers surrounding the coding agent dataset. They try to study different angles, as you can see here. If I pause there, so as you can see, people study the AI IDEs. They try to analyze the inconsistency between the PR description and real code changes. So sometimes agent they describe differently in the text about what they did in the code. And people also study different angles, like the security part, also like how agent fix bugs different from the human beings. And in addition, people also check how to fingerprinting these coding agents. Because right now, developers can configure the agent by hiding the agent attribution. So a lot of people, they build the code locally, leveraging a coding agent, but when they commit it, it's still showing as a human created PRs. It's an open research question right now if you want to study this. And another thing is how can they do the refactoring? How can they build the pull request differently from other people? And how they run the test cases. Also a lot of interesting ideas happening here. So if you're interested, definitely check it out and then to see what you can did or what people already did in a while. And if you miss the challenge, we have more events coming. The first is the EMSC Journal special issue on Agentic Software Engineering. So we are doing a rolling review. It's all about the Agentic Software Engineering. If you have something interesting idea, like good ideas, you want to submit, you can take something and then submit here. We kickstart the review process once you submit it. So The final day is September, but you can always submit earlier, and then we're gonna kickstart it. The other event is the Agentic Software Engineering Workshop, which is gonna be co-located with KDD this year, happening in Korea. And the deadline is June 1st, so you can submit non-paper, short paper. Yeah. So that's all the things. So if you're interested, feel free to scan the QR code to get the book, or you can check my website for the call for papers. If you're interested in the AIDF dataset, you can simply go to get the dataset and then try to build something fantastic from there. And that's all. Thank you so much. Thank you.
Awesome, awesome. Thank you very much, Hao. So I'm going to open the floor now. Do you have questions? Any questions from the participants? Anybody wants to ask any question? I have quite a lot of questions, but I want to open the floor to you. Yes.
I have more like a discussion question. First of all, it was a nice presentation, really good to hear all the advancement. And it feels actually that it's already a little bit outdated because the data is from 2025, right?
Mm-hmm.
Yes.
I want to hear your opinion about, so you mentioned MCP, but currently we have discussion between MCP, skills, and CLI. Like maybe you could comment, what's the next generation of agents? What's the next generation of like integration between tools, agents, and whatever you expect there?
Oh, got it. So the dataset is old, yes. That's why we try to refresh the dataset. And in practice, we observe new things pop up. For example, the plugin ecosystem right now, for example, I'm not sure whether you use maybe you're already aware. There's one very popular project called Superpowers, which bundled a lot of interesting, I would say, artifacts for coding agents. So for example, they have the skill to help people to brainstorming with coding agents. They have different tools to come up with a plan to rephrase the agent. What we can see is the software engineering part for agents is really emerging. So a lot of supporting libraries are designed for agents, not for humans. So I think that's an interesting direction to see. Is like when we treat agents as the new teammates, what's the new capability you're going to build for them in the software engineering part. And the other interesting angle is about the fundamental, like the protocol for the agents. MCP is an interesting direction, and recently Entropic, they donated MCP protocol to the Linux Foundation. So it's going to be a long-lived project and going to be well maintained. But another voice I heard a lot from the community is that people think MCP is gonna dead because it's kind of moving from the surface layer to the fundamental layer, and then the attention becomes lower and lower, and skills pop up because a lot of people right now, the users, the developers, they directly interact with the skills layer, with the hooks layers. That's why I think there are gonna be more things pop up than before. But if we treat them as the artifacts and manage them well and think about the long-term maintenance and security, I think that angle is unique and can be long-lived. If we're focusing on the things come and go, it's quite difficult to anchor or ground our research. And that's my personal opinion. I want to also hear more from the audience about your opinions.
Awesome. Thank you so much. Really appreciate Hao. One thing I really enjoy about the talk, I have to say before I continue with this question, I'm like before other people talk, is you've actually given a very high level overview of the field, which I think is very important. And one thing I love about it as well is you're really involved so much with all of this. And I think this could be a very good way to for other people to really contribute in one way or the other. So, hello.
Yes. So my question was about integrating more about the agentic AIs into automated software development, and I wanted to know more about the security implication of that, because again, we still have these issues with LLMs and traditional AIs that of prompt injection and stuff like that. And I wondered, is there like, since you know a lot about it, it seems, is there a way currently that the tech world tries to mitigate that issue of prompt injection and stuff like that?
Yeah, right now, like the tool we use is called MCP scan. So different people, they try to secure this layer from different angles. For prompt, they also have some tools or models to detect the prompt injection. So different tools are proposed, but I don't think it can solve the problem because like security is all about we have better tools and then people come out with better attacks and we develop better tools defense. It's always going to be this. But the things like in this process, I think the risk be controlled better. Each time we encounter or explore new attack vector, we can protect it better. So that's what we observe in a while. And nowadays, we saw a lot of new sandboxing. They try to control the impact in a sandbox environment. And also, we noticed some incidents that agents incidentally deleted the whole databases because they do not run in a sandboxing environment. I think people really need to think about how we can separate the production environment and sandboxing environment clearly for agents. It's an old practice, but still people did not adopt it very well. That's one angle to solve the problem. Another angle is like, can we build a CI/CD pipeline for the prompts? Because we already know the risk, but why we not building this kind of tools to support developers to run automatic scanning? Can we build a standardized tool to help them so they do not need to run the tools themselves because we can build it on the ecosystem side? So for example, can we build some CI/CD from the GitHub action? Can we build some like action plugin or libraries for them so they can easily use it? That's one angle I can think of. I'm not sure about other domain or AI domain when they think about it, because a lot of tasks right now are happening or the attack are happening in the prompt side. So I think one interesting angle to look at as a security is that can we protect the human beings to make better decisions? So right now, even when we detect the risk, when we throw out the risk, can human make the correct decision? Because cloud code recently they have like if they have high risk operation, they're gonna ask the human being, do you want to proceed? And when human beings they are getting tired, they tend to click the accept. This is some risk we are difficult to avoid. Even we have the super tools, we cannot avoid the risk from the human side. I think it's gonna be an interesting angle to think about how we can help the human beings not need the technology. So there are two sides: how we build better technology for the agents. The other side is not technology. It's about how we manage the process, how we help human beings to make better decisions. That's my point of view. Yeah.
Okay, thank you very much.
And maybe just a follow-up before I ask more question. But why? Because you mentioned this idea of there are so many PRs, right? And
Yes.
For instance, like you mentioned, like you can probably have like 1,000 PRs, and of course, I don't. Why can't we throw agents in the loop? Or do you think that will completely eradicate human in the software development?
It's a very good question. So that's why we are currently doing some research about agentic automated code review.
Hmm.
So if we can improve the performance or make agent automatic review the code, so we can close the loop, and then right now agent write the code, agent review the code, and then it has the feedback loop, agent can receive the feedback and then kickstart, and then they can run long life to solve the goal. And the problem is we notice that agents, they are not that good at review, or they are not that good for mind reading. It's about how agents understand the human intent. The initial intent is not very clear because human beings, we are not good at specify our intention. So
Mm.
interestingly, when we check the reviews in the human PRs, people bring up different questions. Even the same code, if they appear in different projects, maintainers are going to provide totally different feedback from the same code because like different projects, they have different conventions, they have different rules. So I think review is, if we want to build automated review, I think we need to think from the project context. We need to build it specifically for each project. And there's a lot of interesting things can be done for the agentic review. But even like we previously discussed, even we solve all the technical side, we still have a lot of human problems in the loop here. So that's the two balanced thing we need to think about. So we can have a very fully automated process, but once human involved, there are other problems gonna pop up. We also need to manage this part. So these two things to consider always.
Thank you so much. Thank you so much. And maybe that's okay. Please. Sorry.
Yeah,
No,
thank you.
just to say, it's again, if you want to follow up. So it seems to me from your presentation that right now, what you have is increasingly LLMs taking the space of humans in the majority of tasks, and humans being relegated to the two extremes. So hyper, let's say, high-level design still, which is, I guess, still done by humans for a while at least, and hyper precise tasks where in practice we don't trust LLMs yet. But the problem there is that we generate more and more code. So in practice, since generating code is so cheap, you have, let's say, now trillions of lines to analyze, humans get tired and the precision goes away. So this seems to be like kind of like an unsolvable bottleneck from your presentation. So how do you think, if you have to decide what is the strategy that people are gonna, how are we gonna get out of this like quite ugly situation in the next 2 years, 3 years?
Yeah, thank you. It's a very interesting question, and we have been our team has been keep thinking about this. So this problem popped up last year, and this year it becomes a really messy and critical problem in the field. If you check, for example, check in the superpower repository, also check other popular open source projects, the maintainers right now is like they are frustrated because there are so many PRs. They even include agents.readme saying that agents, if you human distribute your code, and you need to ask your human to review the code. If they do not review it, do not click on the checkbox. That's why a lot of PRs, they do not have the box check, like I review the PR. It's always left empty. It's like 90%, they report the number, 90% of the PRs leave the checkbox left. So the human just did not check. And that's one way, I think that's a quite smart way to deal with the AI slop, but it cannot solve the full problem because like we're always gonna get a smarter way to sneak in and then pass the quality. That's why we put a lot of attention to the automated code review to help to automating the process, at least filtering out the low quality PRs. But I don't think that's the full solution because like it always like you have better review, you have better attack, and then you're gonna get in the loop. That's why a lot of people right now start thinking about how can we automatically verify. So instead of doing a review, can we automatically verify the code? Can we adopt the formal methods to the proof? So we do not need a review process. That's why in this year's ICSI, Peggy, she mentioned an interesting viewpoint saying code review is dead. Even though I disagree with that, maybe in the coming year, code review is going to be dead, but it's an interesting direction to go. Like, can we, in the initial phase, when humans specify the intent, can we have a loop to make the intent very clearly specified, like in the proof? So we can use the proof to verify the implementation. Then the code becomes the binary layer, like nowadays. If we have the correct proof, correct intent, we do not care about the code because any agent can generate the code, can regenerate the code and pass on the proof. I think that's one interesting angle to think about it. Yeah, and that's my answer. I'm not sure whether it addresses all your concerns.
The best you can do, but thank you. As much as it's possible to answer. Yeah, thank you very much.
Thank you.
Yeah. Thank you so much. Any other questions? Okay, while you're thinking about a question, I have this consent from slide 31. Right, so in slide 31, you mentioned about this notion of security and functionality and performance being questioned. Can you kind of elaborate on that? I want to actually like understand what you're trying to say as far as this is concerned, please.
Oh, yes. So here we check the agents.readme or cloud.readme. So user will mention in a README file saying, when you implement some features, here's the architecture you can refer to. Or when you implement a detailed function, you should use this library instead of that library. That's the implementation details. And for the build, it's like they told the agent, you can run this command to build a project. You should run this command to do the integration testing. You can run this command to do the unit test. And for performance, it's more like when you do something, try to improve or optimize the performance, not only about implement the functionality. For security, normally they are about like use something carefully or do not leak the functions, but it's very rarely covered. So we do not have that many instances. So one research idea we think about is like, can we extract these requirements about performance or security? And then we human manually select the high quality ones. And then we try to see what's the impact of this kind of instructions. So it's like without the instructions, does agents care about this kind of aspects? If we include a prompt or security prompt, can they have better security performance? Because nowadays we also saw a lot of research pop up. They run traditional vulnerability scanning code for the agentic PRs. They also found a lot of vulnerability from the generated code from humans, from PRs, sorry. So I think that's a one interesting angle to check this point. And for performance, another interesting angle is about benchmarking. So we saw a lot of benchmark about the security, and for performance, the unique angle about performance is that the performance can have a infinity improvement, like, or there's a upper bound, theoretical upper bound for some algorithms. It's not like the functionality correctness. For sweep range, we have like pass rate, we have passed or not. For performance, it's like you can always ask an agent to be better. Like it's a very good measurement for the agent performance. So we do not need to care about whether we have a good testing to check the correctness. We can have the performance testing to see whether agents are keep improving or not. I think that's another angle to think about it. Yeah.
Awesome, awesome. Thank you, thank you. Any other question before I ask another question? Okay, okay.
You mentioned the amnesic problem when it comes to agentic coding, where every time you enter a code base, it forgets everything. To what extent do you believe that things like Hermes can solve this issue? Not Hermes, Hermes. Yes, I don't know how to properly pronounce it.
Okay, so sorry, but I also do not know the tools. I think it's a memory system.
It's similar to, I think, OpenClaw in a sense, but it does automatic context management.
Got it.
Apparently it's good about it, but yes.
Now assume it's a memory system, like it's one way to solve the problem, or people can't try to solve the problem. And then it always go back to the same fundamental issue is about how to retrieve or how to manage the context file. Because if then there's two different ways. One is like very naive way. If we recall everything and then when agents start a task, it just reload everything. If we keep doing that, it's gonna totally overwhelm the context window. So agent cannot handle it. That's why people start thinking about how we can build a smart system to manage in the context. Can we compact the memory? Can we retrieve the correct memory? Can we get the same thing? But it introduce a lot of new problems if we design a system, like how we compact it and how can we make sure that retrieve the memory is correct or most useful for the current tasks. And then how can we decide which memory to be recorded? It's like multiple things gonna happen when we build a system. That's why I think a lot of new research, they are trying to solve it. They even like recently, I think one people developed a plugin or Cloud Code introduced a new tool called Dream. It's like dreaming like human beings. It's gonna run an automatic cleanup for the memory. So they're gonna try to going through the memory to try to do the compact cleanup and the storage to make them easier for retrieving next time. I think that's also one interesting angle to look at this question.
Awesome. Thank you so much. Maybe another question from me is there a way, while you were talking, you talked about like how different agents, but my question itself is there a way to actually fingerprint a particular agent? Can I know exactly if, let's say, Cloud Code was the one that wrote this, or Codex was the one that wrote this, or is there a way to do that?
Sorry, can you repeat the question?
So my question is there a way to actually fingerprint what agent wrote what?
Oh, yeah, it's a interesting question because like in the MSI challenge, we got one paper about this. And
Okay.
then the key finding is like they found out it's very easy to build a simple, like traditional machine learning model to detect
Right.
which agent wrote the code.
Interesting.
Yeah,
Wow.
I think because they are training in a or they are post-trained in a very different style. So each agent have their own language style, like coding language style. That's why they are quite easy to detect. It's like in recently a lot of people saying like this is not something, this is something else. It's a very classic pattern of agent language model speaking language when they have that very weird patterns. In coding, we also observe similar things. So I think it's doable now, but in the future we do not know because like once they have similar post-training data set, they're gonna
Right.
behave more like the average AI. And if their average AI is very difficult to distinguish the agents. So in the
Right.
future, it's gonna be a bigger problem than right now, I think.
Interesting. Awesome. Yeah, we have 3 more minutes. Yes, let's go for it. Anyone?
Yeah, it's kind of like you made me think about it. So like increasingly code is written by LLMs. So increasingly you can only learn by LLMs. Is this so up to now, let's say they were kind of like learning to be like humans. As in you had data that are written by humans and you learn to imitate the behavior if you want in a very, let's say, high level. What happens when the code is generated by LLMs? Like, do you get into weird self loops in training? Do you get in situations where you keep on, let's say, distilling the same mistake worse and worse every time? Or is actually going to be the hack to, let's say, get infinite training data?
Okay. One interesting argument I heard about this is like the nowadays language model is the worst language model we're gonna use in our life. And it's true for the past. It's keep improving. Like if we think 1 year ago, language model cannot even write proper code, and then some of them cannot write proper code, but nowadays people are using them daily. So I think next year we're gonna see way much more powerful language models for generating code, but we're still gonna get a lot of problems. So the problems are always gonna stay there. So no matter how good the language model gonna be, because always like the two sides of the problem, agents and humans. So no matter how good an agent gonna be, human gonna always evolve here, and then we need to do something for the process. That's one way to answer the question. But I'm not sure whether I have any follow-up about this, but I think it's a very interesting discussion point if you want to follow up here.
Okay, good. You have a question? No. Okay. One last question from me. Okay. Okay. One last question from me. So my question is, if I understand most of your presentation correctly, human seems to be the bottleneck. Is that correct?
I'm hesitating to say, but currently, I think yes.
Okay, interesting. That's a good one. Now we know. Right. Okay. Yeah, because the reason why I'm asking is it seemed to me that like a lot of things the agents can do, no doubt at the moment. And I think your word about or your sentence about the fact that the current models are the least in which we'll probably is probably the worst in which we'll probably use in our entire lifetime kind of shows this direction of will agents replace humans?
Wow.
Yeah, we have 1 more minute, but let's have your take on that. Do you think agents will eventually replace humans?
I don't think so. It's like
Okay.
we can call it human bias. Like we are biased. We are building things for us. We are, as a species, we are selfish. As human beings, we are selfish. So I don't think we're gonna build something to replace us. We're gonna build something to enhance us. That's my short answer.
And thank you so much, Hao. It's such an interesting time. We really appreciate it. We look forward to more collaboration. I'm sure I'm going to reach out to you again.
Yes.
And thank you so much, everybody, for joining. Yeah, take care of yourself.
Thank you so much for being here.
Thank you, everybody. Yeah, thank you so much. Yeah, bye-bye. Yeah,
Bye-bye.
Bye. Bye.